Today's focus is on tables, tree diagrams, and lists. Now, really our focus for today is tables because yesterday you created tree diagrams, and using your tree diagram, you resulted in a list. Now, we're going to talk briefly about how you can go straight from information to a list without needing a tree diagram, but there will be times when making a tree diagram is still going to help you to ensure that you have all of the possible outcomes listed. First, how to create a table to show possible outcomes. You're spinning a spinner and rolling a die. Now, yes, we could certainly have created a tree diagram and used the information here. It's going to be a much bigger, much messier tree diagram. The chart, since it's only two events, will show the information much quicker and much more organized way. So notice how I've taken my outcomes for the spinner, which are red, yellow, blue, and green, and I've listed them across the top column here. I've taken my possible outcomes for rolling a die, which are 1, 2, 3, 4, 5, and 6, and I've listed them in the first column here. Now, in order to come up with a chart, we're going to work down each column and across each row. So notice, first column, all of those outcomes are going to end up with a red in their outcome. My first outcome up here is going to be red, but it's also going to be 1. So we end up with a red 1. My second outcome, a red 2. My third outcome, a red 3. My fourth outcome, a red 4. My fifth outcome, a red 5. Number 6, a red 6. Now, each of these outcomes is stating I can spin a red. I can get a 1 on the die. I could spin a red. I could get a 2 on the die. These are all possible outcomes. Now we go to our yellow column. Yellow was a possible outcome on the spinner, so I could get yellow for any of these events in this column. And then notice the 1, 2, 3, 4, 5, and 6 roll right across, so we have a list of outcomes. Next column, blue. Every response in this column is going to be blue. And then again, we carry over the 1, 2, 3, 4, 5, and 6. In our last column, every response is going to be green. And then again, we carry over our 1, 2, 3, 4, 5, and 6. Now, yesterday we talked about the fundamental counting principle. And the fundamental counting principle said that if we had m events of one type and n events of another type, and we combine them, we're going to end up with mn events. So notice I have 4 events or 4 possible outcomes on my spinner. I have 6 possible outcomes on my die. 4 times 6 should give me 24 outcomes. If I don't have 24 possible outcomes in my chart, then I've done something wrong with my chart. So I have 1, 2, 3, 4, 5, 6, 7, 8, 12, 16, 20, 24. Now, the nice thing about a chart like this is not only does it present our information nice and neatly, but we could start to answer questions about probability. I could say, what is the probability of spinning a yellow? And we would look and say, oh, 6 out of my 24 outcomes ended up in yellow. 6 over 24 reduces then to 1 out of 4. We could ask a more specific question like, what is the probability of getting a blue and an even number? So we would want to look for where is there a blue even number. B2, B4, and B6 are blue and even. So there would be 3 out of my 24 total outcomes that are blue and even. Then we reduce our 3 out of 24 to 1 over 8. And we end up with a decimal fraction and percent as our solution, but we'll talk about that at a later point in time. Creating a list of possible outcomes. Now here, you notice the directions do not say to make a tree diagram. They do not say to make a chart. You are certainly welcome to do either a chart or a tree diagram, because when you finish either a chart or a tree diagram, you are left with a list of possible outcomes. You are also welcome at this point to just list the possible outcomes. So I know I'm going to have a red shirt with yellow pants. Blue jean pants. I'm also going to have a red shirt with yellow pants. I'm also going to have a red shirt with, what are these? Another set of blue jean pants. Well, those were all of my possible outcomes for me wearing a red shirt. But I also have a yellow shirt, so I can list my possible outcomes for wearing a yellow shirt. I can wear a yellow shirt with these blue jean bell bottoms. I can wear a yellow shirt with yellow pants. And as my students tend to notice, that ends up being the man in the yellow hat from Curious George. Or I can wear a yellow shirt with blue jean bottom pants. So that's a real quick, easy list. I should notice that on my list I have 6 outcomes, which makes sense. I have 2 possible outcomes for one event. I have 3 possible outcomes for my second event. 2 times 3 is 6, so I should have 6 total possible outcomes for the combined events.